Dear friends, today's topic is integration. As you know, integration is the inverse process of differentiation. We have already discussed on it. Instead of differentiating a function, we are given the derivative of a function and asked to find the primitive. Okay, that is original function. As you know, the derivative of sine x, the derivative of sine x is equal to cos x, isn't it? So the antiderivative of cos x is sin x, isn't it? Derivative of sin x is cos x, but the antiderivative of cos x is sin x. For this is the reverse process. Integration is the reverse process of differentiation. Okay, so if I have a derivative of sin x plus a constant, say arbitrary constant c, then again I am getting derivative of sin x as cos x and derivative of the constant c as 0. So we are again getting the same derivative. Okay, sin x plus c, its derivative is cos x, and again the derivative of sin x is also cos x. Means if I get the antiderivative of cos x, then the integrals, the antiderivatives of cos x may be varied. It may be sin x, it may be sin x plus c, it may be sin x plus 1. This c is a real number. Okay, so there are different types of real numbers. It may be 1, 2, 3, 4, minus 1, minus 2, like this. So you are getting so many antiderivatives, that is the integrals. Okay, thus an antiderivative or the integrals of the above cited function are not unique, isn't it? Actually, there exist infinitely many antiderivative of each of these functions, which can be obtained by choosing c arbitrarily from the set of real numbers, isn't it? So this constant c is actually arbitrary constant, and this c is known as also the integration constant. So reverse process, the sign is this one, integration of cos x with respect to x. So it will be sin x plus c, where c is an arbitrary constant, or you can say that c is an integration constant. Okay, so according to the values of c, the integrals may be different. What is cos x? Cos x is the integrand. This is your integrand, and the result, this result is known as the integral. Okay, integral. So the antiderivative of any function is giving you the integral. Okay, now I am giving some formula, and these are the basic formula of integration. Integration of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus the arbitrary constant or the integration constant c. Integration of dx means integration of 1 dx actually. Okay, 1 dx is equal to x plus a constant c. As I said, it is the antiderivative of a function. If you differentiate this one dx of x plus 1, x plus c, you are getting 1, isn't it? Derivative of x is 1 and c is a constant, its derivative is 0. So you are getting 1. And integration of cos x is equal to sin x plus c. Integration sin x dx is equal to minus cos x plus c. These results are given here. You just stop the video and you write the formula in your formula list. Okay, now is the square. I am showing root over x minus 1 by root x whole square dx. Very simple, as it is a minus b whole square, like the format. So this will be x plus 1 by x minus 2 times so root over x into 1 by root x. Root x is cancelled. X is not 0, obviously. This is dx. Okay, you split this one, integration of x dx plus integration of dx by x minus 2 times of integration of dx. 2 is a constant, so you can take it out of the integration. Okay, what is the integration of x? As you know, this is x square by 2, and log of modulus of x minus 2, and integration of dx is x, and you have to put integration constant c, and this is your result. Okay, very simple question. Integration root over x minus 1 by root x whole square, its integration is this one. So this type of question may come in your exam for 2 marks or 1 mark also. In 1 mark you will get the options, 4 options will be given, and you will choose the correct option. Okay, next question please. Another one. Yes, this is number 14. Okay, integration of 1 minus x into root over of x dx. And what will you do? You just follow the distributive property. 1 into root over x, that is root x, minus x to the power 1 plus half, that is 3 upon 2 whole dx. Okay, so you must separate the integration x to the power half dx minus integration of x to the power 3 upon 2 dx. So very simple. Which formula will you use here? The basic formula, x to the power n, that is x to the power n plus 1 divided by n plus 1 plus integration constant c. So like this way, here you will follow this one, x to the power half plus 1, that is 3 upon 2 divided by 3 upon 2. Okay, minus x to the power 3 upon 2 plus 1, that is x to the power 5 by 2, isn't it? 5 by 2 divided by 5 upon 2 plus the constant c. So this is 2 upon 3 x to the power 3 by 2 minus 2 upon 5 x to the power 5 upon 2 plus c. That's the result. Very simple question. Okay. Another important question, I think it is question number 18. It came in the previous years. Question number 18. This is integration of sec x into sec x plus 10x. Sec x plus 10x dx. Very simple. Again, you follow the distributive property. Integration of sec square x dx plus integration of sec x into 10x dx. Okay. So what is the integration of sec square x? You know, this is 10x. As you know, what is the derivative of 10x? The derivative of 10x is equal to sec square x, isn't it? So what is the integration of sec square x? So it will be 10x, obviously, isn't it? So integration of sec square x with respect to x is 10x. Similarly, it is sec x, and the integration constant is c. So the result. So 18 is also done. Another interesting question, I think this is 20. Okay, question number 20. Integration of 2 minus 3 sin x whole upon cos square x dx. This is an important question for 2 marks. Again, integration 2 upon cos square x dx minus 3 times integration sin x upon cos square x. Okay, cos square x dx. So what is this? 2 is a constant, it is outside of the integration, and this is sec square x dx minus 3 times, and it is sin x divided by cos square x. One part is sin x by cos x, that will be 10x, and another part is 1 by cos x, means your sec x. Integration of 10x sec x dx. So what is the integration of sec square x? As you know, it is 10x, and integration of sec x into 10x or 10x into sec x, it is sec x, and the arbitrary constant, the integration constant is c. F of x is equal to 4x cube minus 3 upon x to the power 4, and f of 2 is given 0. Then what is the function f of x? Okay, so what is given? ddx of f of x is given. Again, you write this one, 4x cubed minus 3 upon x to the power 4. Okay, now this is d of f of x is equal to 4x cubed minus 3 upon x to the power 4 dx, isn't it? Now integrate from both sides. Okay, integration of d of fx means your f of x, and integration, you split this one, integration 4 times of integration of x cubed dx minus 3 times of integration of x to the power minus 4 dx, and this is 4 times of x to the power 4 upon 4 minus 3 times x to the power minus 4 plus 1, that is minus 3 divided by minus 3 plus the integration constant c. On the left side it is f of x. Okay, now since it is asked to find out your function f of x, and what is given? F of 2 is given. F of 2 is equal to 0. So from this condition, f of 2 is equal to 0, you can find the value of constant c. Okay, so what shall I do now? I shall put in place of x as 2. Okay, then it will be f of 2. Okay, f of 2 is equal to here 4 is cancelled. F of 2 is equal to 2 to the power 4, and 3 is also here cancelled. Okay, so plus 1 upon x to the power 3 means 2 to the power 3, and the constant is c here. And what is given? F of 2? F of 2 is given as 0. So 2 to the power 4 means your 16 plus 1 upon 8 plus c. Okay, what is c? Then c is minus of 16 plus 1 upon 8. Okay, 16 plus 1 upon 8. So this is 8, 48, 4, 8 1s are 12. Okay, 128 plus 1. So this is 8 minus 129. So c is here found as your minus 129 divided by 8. Then what is the function? I as f of x is equal to x to the power 4 plus 1 by x cubed, and c is found as minus 129 divided by 8. The answer is found as f of x is equal to x to the power 4 plus 1 upon x cube minus 129 divided by 8. Okay, so from the list of the options I find the answer is A. Okay, x to the power 4 plus 1 upon x cube minus 129 divided by 8. Okay, these are few important questions taken from exercise 7.1. I think these will help you. Please practice.